Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on thermal physics from March 2021, paper 4, variant 2. For part A1, question is asking us to calculate the number of molecules in the gas. But for this question, temperature of the gas is given, so simply we can say this is temperature. And the pressure of the gas is given, simply we can say this is P. And volume of the gas is given, so simply we can say this is V. Now we need to calculate number of molecules in the gas. So the first thing you need to consider is that PV is equal to nRT. In this equation, you don't see number of molecules, but N is here. N is the number of moles. So first thing we can calculate is number of moles. So we can calculate number of moles will be equal to PV divided by RT, and T has to be in Kelvin. So you have to be very clear about that. T must be in Kelvin. So it has to be in Kelvin. So let me write on here. It has to be in Kelvins. If we can get number of moles. When we have number of moles, then we can calculate number of molecules. So this will be our first step. In the second step, you can write down number of molecules divided by Avogadro's number. This is equal to number of moles. So from here, we can calculate number of molecules. This will be equal to number of moles times Avogadro's number. So you will get your final answer. Means if you follow these steps, you have to do this one in 2 steps if you use this method. But now we need to understand how we can do the same question just in 1 step. So for that purpose, you need to understand PV is also equal to NKT. K is the Boltzmann constant, N is the number of molecules. So here, if you use this one, so you can say PV divided by K times T. Temperature has to be in Kelvin, so you can calculate number of molecules directly. Now let me explain to you how you can convert this one into this form. So from here, you need to understand N. For example, N you can replace with capital N divided by NA. So N we can replace from here. So I'll be writing here. So this is PV. And so N you can replace with number of molecules divided by Avogadro's number and times RT. From here, we can also understand R over NA. This is equal to N other constant. So we can write down now PV. This is equal to N, and R divided by Avogadro's number means gas constant. If you divide by Na, this is equal to Boltzmann constant. So simply we can write down here PV is equal to NKT. So this is how you can convert this equation into this one. Now simply we have the formula, we have all quantities, the values are given, simply plug in and you can find the answer. This is how you can do the calculations. This is important point, you have to be careful. Temperature has to be in Kelvin and rest is just simple calculation. And this answer has to be in 2SF because the least number of SF we have in our raw data, 2SF. So our final answer also should have 2SF. So this is how you can write down your final answer. This question has 2 marks. The first mark is if you follow this one, the first mark will be for this step. If you have written N is equal to PV over RT, and the second mark is if you have done this step and you got the right answer, so you will get answer mark. So this has 2 marks. But in this case, if you have used this formula, this will give you 1 mark. And the final mark is answer mark. You will get answer mark if you got the right answer. For the second part, question is asking us to determine the root mean square speed of the gas molecules, mean RMS speed of the gas molecules. But the mass of one molecule of the gas is given, that is equal to 40 U. So question is asking us about speed of the gas molecule. So it means that we need to consider kinetic energy of gas molecules. So we will start from here. The average translational kinetic energy of gas molecules is equal to 1/2 m times mean square speed. So this is mean square speed. This is how you need to write down. And this is equal to 3/2 kT. 3/2 kT. And K is a Boltzmann constant and temperature has to be in Kelvins. Very important. Temperature you have to use in Kelvins. We need to calculate mean square speed. So simply first thing we can do is we can cancel 1/2 here. We can cancel with this. So now if we rearrange this one, we can write down mean square speed. This will be equal to 3 times kt divided by m. Means we're just dividing by m on both sides. Now we need root mean square speed. So it simply means that we have to take the root on both sides. So we will take root on this side, and we also have to take root on other side as well. Means square root. We will take root on this side. So this speed now, this is CRMS, means root mean square speed. Now simply we need to plug in values and we can calculate RMS speed. Now you can pause the video and you can do calculations first by yourself, and then you can come back and you can compare your working with my working, and also you can compare your answer with my answer. So take some time and do calculations first by yourself. I hope you have done calculations. Now look at my answer now. In this question, you can see here what we have done is that simply we have plug in values. So this is the value of the Boltzmann constant, and this is the temperature in Kelvins. So you have to use temperature in Kelvins. And this is 40U. 40U is given, but 1U is equal to this one. So you have to convert this one into kgs, not in U. So that's the reason we have to multiply with this one. And this is our final answer. This has 3SF. So we can write down in this form, we can write down this is 4.3 times 10 to 2. So means it has 2SF. So this is our final answer. This question has 2 marks. You will get the first mark if you have used the right formula, and this is C mark. And the final mark is answer mark. You will get the final mark if you got the right answer. This is how these 2 marks will be awarded. For part B, it is given to us the temperature of the gas increased by 84 degrees Celsius. Increased by. So it simply means that the final temperature, this is equal to initial temperature plus 84 degrees Celsius. If it was written here increased to, then simply you can say the final temperature will be equal to 84 degrees Celsius. So you need to be very clear what is meant by increased by and what is meant by increased to. So this is kind of common mistake made by many students. So you have to be very clear about the language of the question. Now question is asking us to calculate the ratio between new RMS speed of molecules to original RMS speed of molecules. Means you have to divide new RMS speed by original RMS speed of molecules. Now temperature is higher. So for this purpose, simply you have to start from here. So CRMS, we have already derived this formula. This is equal to 3 kT divided by m. So this is 3 kT divided by m. Now from here you can see this is T here. We can write down this one in this form. We can say this is 3K divided by m. You can simply write down here this is root of T. We can divide by root of temperature on this side. So we also have to divide by root of temperature on left side. And this one we can simply cancel. So simply from here you can say CRMS means root means square speed of molecules divided by temperature in Kelvin. This is equal to 3K divided by m, the mass of one molecule. If you look at this side, you can see 3 is a constant, K is a constant. This is Boltzmann constant, and m is mass of molecules. That is also constant. This is mass of one molecule. So simply we can say this is equal to some constant. The ratio between these two, this is equal to constant. So if temperature change, it means CRMS will change. So simply we can say that CRMS new divided by the T new, the root of this one, this also will be equal to constant. And these two constants, they will be same. So from here we can write down CRMS new divided by the root of T. This will be equal to CRMS original. I can simply say this is original, and this is new temperature. We can say this is new temperature divided by this is over initial temperature. So we can say this is original temperature. Now simply we need to rearrange them and we can find our final answer. So if we rearrange this one, so we will get here CRMS new divided by this one. So we can say CRMS original This one will be equal to the temperature T new. So this is cross multiply. So this is T new divided by T original. So this is original mean initial temperature. Now simply we have to divide these two and we can get our final answer. So the new temperature is 21 plus 84. It has to be in Kelvin. So this is how you can convert into Kelvin. Divided by initial temperature, that was 21 degrees Celsius. We have to add 273 to convert into Kelvins. Now, if we do this calculation, our final answer, you can try first by yourself, but if you have done in the right way, your final answer will be equal to this. So we can write down our final answer is equal to 1.1 up to 2 SF. So simply we can write down up to 2 SF. So this is our final answer and this is how you can do. I have explained in detail, but in exam you can do quickly. You can skip these points. You can quickly go to this one. This question has 2 marks. The first mark you will get if you have written this relationship, means you have written in this form. So simply we can say you will get C1 mark. And the final mark is the answer mark. If you have got right answer, you will get the second mark.